Hey guys, today we're going to talk about the single most important thing for being an instructor, which is skepticism, right? Do not believe the students. Don't believe them. No matter what, don't believe them. So I do not accept anything weird. I never accept anything weird because it usually uncovers crazy stuff. This is a little bit easier for me because I've been doing this for many years, and so I have a vast knowledge bank of times when I did allow students to do weird things, and it turned out later that those weird things were not just slightly weird, hugely indicative of massive gaps, massive misunderstandings. It wasn't just a small thing, right? So if they do weird orderings, weird sizing, weird orientations, anything like that, it's usually a worse sign than you would ever think, right? So don't treat anything like a little deal unless you specifically talk to your lead instructor and they say that it's not a big deal. But most of the time they're going to tell you that it is a big deal, so there's that. For example, what if they type BA instead of AB? You've got to be a skeptic, right? That's weird. If they're doing distribution of A times the quantity B plus C and they give you BA plus CA, that is a very, very strange answer. There's no real reason to transpose those letters, like, logically, which means that somewhere along the line, some type of complete and total illogic is happening in that student's brain. And big deal. Okay, so do not accept it. Definitely don't accept it for sure. But just try to think about, why are they typing it that way? It's just super bizarre and usually indicative of these underlying gaps or fears within math, right? Really, really big stuff beneath that. If a student writes t times 1/4 instead of 1/4 times t, it's technically right. It's totally wrong. Technically right, totally wrong. Okay. This is just not the way that we write things. Why is that student putting a letter in front of the number? That's just not how we write it. Okay. So very, very simply just say, hey, by the way, that's not how we do it. Let's do it this other way. No matter what you do, don't ever let the student go on. Don't just say, okay, yeah, let's do it that way next time. No, you got to stop right now. You got to completely redo all the steps so that the steps look legitimately good. That is how you break bad habits. If you allow the bad habit to continue, it's never going to end. Okay. So do not allow that bad habit. You've got to break that bad habit right the second that you see it, immediately. If you allow the student to write nonsense math, so if the student is writing nonsense math at any point, they won't understand it. That's kind of the whole point of nonsense math. If they write stuff where you have to scratch your head at all in order to understand what they are saying, no, right? Usually what I'll go with is just a simple, clarify, explain, what did you do in this step, something like that. Don't give them hints, obviously, but make sure that you actually understand and then have them rewrite it in a way that's much more clear, right? That's kind of the idea over here. This is what I usually actually say to my students. Until you are a math genius, you are not allowed to write it any abnormal way. You have to write it the normal way, and there's only one normal way. It's widely accepted. This is it. This is what we get. Now, technically, there are some other ways, but this is what we're going to go with, right? This is the way that we write it. When you are a math genius, you probably just won't write it that way. There's not a lot of math geniuses who go around being like, yeah, BA plus CA. They just don't do that because it would be weird, right? That doesn't really happen. So, one other further point that I explain to students, if you're doing insanely hard math because you're a math genius, right? Then the last thing you want to waste brain space on is where this or that letter goes. That's just not what you want to do. You're not sitting around being like, oh, should I put the A first or the B first or the fraction first? Which one goes first? That's not where you want to be because if you're there, then you cannot possibly achieve math genius status. It's not going to work. So, not that. You put it in the exact same place every time. You develop one very clear system. That's it. You don't deviate. That is how you do it when you're a math genius. You have a system and that's it. I know sometimes you get savants who do really crazy stuff, but that's not the point, right? If you're going to be really good at math, this is how you're going to do it to conserve brain space. You can explain any or all of this to your student in order to convince them, but at the end of the day, they have to write it the right way. They have to write it in the most logical, the most sane way, and in the most normal and widely accepted ways. Most students cannot think about what they're doing at all in math. this will become apparent. I'm going to give you some examples, but this is like super, super critical to remember. Just because a student is doing something doesn't mean that they are thinking about what they are doing, okay? Most students memorize a lot of processes. That's just how they get, through math, right? They go around, they memorize this process, this process, this process. The reason they can't do well on the SAT is because they get into the SAT and they have no clear idea which process they are supposed to be using. And so they just kind of wildly guess, right? And they throw stuff down and they, maybe I'll just, I don't know, I'll number punch. Okay, I'll go with calculator method. Well, okay, and that fails them. Or they do the SAT guessing method, which is, ever so wonderful. And so they don't do well, right? But it's because they're literally not thinking about what they are doing. Okay, they're just doing, but not thinking about it at all. That is super evident if you ever ask a student, okay, cool, can you explain to me in words what you did in step 2? They almost certainly cannot. Just almost certainly cannot. Unless they are a very advanced student, they probably cannot. So we want to make sure the right things become habit so that what they do is always correct. And then once we get there, then we can start to think about what they are doing. If what they are doing is wrong, if they're writing BA plus CA, which is terribly, terribly wrong, then they will never be able to think about what they are doing because they're still stuck in the phase of doing it wrong, right? So we got to get them through that phase first. One example. One former student of mine was drawing sloppy triangles, okay? This is a really, really weird thing. I told her, several times. I was like, okay, well, I'll draw a line. Here's a vertical line, okay? You copy this vertical line. She could not, after several attempts, manage to create a perfectly vertical line. Or perfectly horizontal, didn't matter. Like squiggly lines, the lines weren't even straight, right? Half of them would be like a curve. I mean, like a dramatic curve, okay? Just part of a small circle, okay? Dramatic curve. Minimum 30 degrees off, it would be a line like dupe. And I'm like, that's a 40-degree line. That's not horizontal or vertical. She just totally didn't get it. It turned out she had very severe deficits in spatial reasoning. This is probably obvious based on this description. But if I had just accepted the squiggly weird triangle that she first gave me, the very first one, I would never have uncovered this. I would never have known, and we would never have developed our spatial reasoning curriculum. And we would never have gotten to a place where we can recognize and understand and apply that curriculum in various places. None of that would exist inside of what we do because I just passed off something that was okay but kind of weird. It's not okay, right? Huge, huge thing. Not okay. Couple of statistics for you. Around 80+%. So I am probably over 80%. I'm being conservative. 80+% of our students fundamentally do not comprehend functions. This is a thing that I am discovering only within the past 6 to 8 months or so. They have memorized many, many processes, right? I mentioned. They memorize lots of processes, and so it always looks like they get it, but they can never explain that stuff in words. They can't do it. 80+%. That is massive. The vast majority of students that you will work with will not actually fundamentally comprehend functions at all. Hopefully that makes you more of a skeptic, right? Hopefully it makes you a bit more of a skeptic. They don't comprehend equations. They don't comprehend functions. They just don't get it. 75+% of our students have completely forgotten all mental math due to calculator usage. All mental math. We're talking hey, what's 8 times 4? Oh, 18. Nope. Okay. Cool. Definitely not 18. Okay. And you have these moments, you'll have these moments as an instructor where you're just oh, wow. Oh, I had no idea. It's not like they're guessing 1 or 2 numbers off. We're talking wild misinterpretations. Most students do not know that multiplication is repeated addition. They have no idea. They don't even know that those two things are linked. They have no idea what's going on in the world, at all of math, right? 90+% of our students do not comprehend the meaning of an equal sign at the fundamental level. This is the thing that we've discovered recently, also within the past 6 months or so. The students have seen it used, they can write it on their paper, but it's just memorized processes. Like they don't really get it. They don't understand why you have to add the same thing to both sides of an equal sign. They don't understand why if m equals 7, you can add m to the left side and 7 to the right side of some other equation. They do not understand like any part of that at all. So it's your job to constantly be a skeptic and say, hey, do you actually get this? Hey, let me ask, more inquisitive questions. Why did you do that thing? Can you explain your step to me in words? A lot of times we have to teach them the vocabulary because they lose the vocabulary for math because math is very much about doing, and so they don't ever talk about it. So you do have to have a step of saying, okay, yeah, we call this, a whatever. We call this or this thing. You'll have that step, but they can't, even after that, they still can't explain it in words. They still get just crazy, crazy stuff you'll get out of this, right? So most people do not understand even the equal sign, like what might be considered the most basic aspect of like pre-algebra. They don't get it, okay? Students can and will and do misunderstand every single thing that you think no one could possibly ever misunderstand. Okay. Anything that you think that you're like, oh yeah, nobody doesn't get that. Like that's like super obvious. They don't get it. And they don't get it in like the most deep and like visceral way possible. It's deeply ingrained inside themselves. It's usually based in fear. It's usually based in like years and years of just lack of understanding and covering it up with nonsense upon memorized processes. They don't get stuff. And that's why they come to us, and that makes sense. But as tutors, a lot of times, like we see tutors in the world as, oh yeah, you just kind of show up and you say, okay, you don't know this like one thing. Okay, so here's how you factor. And then the student learns it and then you're just like, oh, okay, cool. My job's done. Like that's it. It's not, right? These kids don't know anything and they don't even know how much they don't know. And it's very, very tragic, but it gives us like a purpose, right? I mean, it gives us like meaning to our lives and to our work. So, never assume that a student knows anything at all until you personally have verified or discussed it with another instructor who has. Just hopefully what you take out of this video is that you should be more skeptical, more and more skeptical. And if you're like, a level 10 skeptic, like just become a level 12 skeptic. Invent a new level of skepticism. This skepticism will catapult your real teaching ability to a much higher level, like overnight. Seriously, overnight. In math, you will start to discover instantaneously, holy crap, students really do not understand like any of these things at all. I mean, it's so much. Hopefully this helps you. If you have any questions about this, totally let me know. Talk to your lead instructors. They probably have other examples of times when they were not skeptical and it turned bad, or were skeptical and then they were shocked by how much the student really didn't know. It's super common. If you're here for a year, you're going to experience it yourself 1,000,000 times over. But look for it, right? Be a skeptic, be skeptical, and stay awesome.